If you remember on Friday, we were introduced to equilibrium constants and the different ways to look at it. However, all of Friday's problems were situations where you were given the equilibrium concentrations and then you use them to solve for K. We'll call those the simpler types of problems, but they definitely exist on AP, so it's good to know. More commonly, there will be missing concentrations for the equilibrium concentration, meaning instead of getting just a plug and chug to solve for Kc or Kp, you'll need to figure out those concentrations at equilibrium. The way that we do that is by using what's called a rice table. It's fried rice, so most people like it. No?
I love fried rice.
I like fried rice too, unless there's egg in it. Why do they do that?
You don't like egg?
No, I don't like egg. No.
I hate egg, but I like egg in my fried rice. Yeah.
Well, roosters don't lay eggs.
They definitely lay eggs.
The roosters don't lay eggs.
I thought they were boys and girls.
Now, Isaac, you are very sure. I like confidence. I like that.
I thought that they were
I
like
want you show me a video of a rooster laying an egg. I want to
I
see
thought
it.
that the boys, I thought they were like frogs. You know, like same gender in one.
Right. Hermaphroditic.
Hey,
You say so.
We win some, we lose some, right? I go ahead and take it.
All right, so let's take a look at some facts about rice tables before we use them to solve. As I already said, they're going to be used to find equilibrium concentrations when we don't already have them. Basically, what it's going to look like, guys, is we're going to do an RICE, and there's information that goes in each row. So we want to know what the rice stands for. R is going to stand for the reaction. Keep in mind, though, for us to do equilibrium, we're required to have aqueous and gaseous only. Well, that's for K and Kc. What's true for Kp? Gaseous only if it's Kp. I is going to stand for initial concentration. Since we're not being given equilibrium concentrations, we're going to be told what the reaction looked like at the beginning. And we want to figure out what it's going to look like at equilibrium. And again, rice will help us do that. However, the initial concentration must be in molarity or pressure. The reason I like to point that out is a lot of times the AP questions will give it to you in something like moles, in which case, well, moles is no good. It has to be molarity, but you know how to find molarity. You would just divide it by volume. So just don't get tripped up on little things. The C stands for change. The change is going to call back to one of the ideas that we did on the equilibrium graphs on Friday, where we know that the reactant amounts always go down while the product amounts always go up. And that's going to help us figure out what the change will be during the reaction. And then finally, the E is equilibrium, which is what we're looking for. And to find the equilibrium, it's simply the sum of I and C. So let's make sense of that with an actual example. Make sure you have your slides at home. I forgot to say that. All right, so we got a problem. Let's take a look at them. What I notice right away is it's starting not at equilibrium, because if you look halfway through the question, it says, okay, well, after equilibrium, it looks like this. So that's a good indicator that a rice table is needed. And you can see, though, that it's asking for equilibrium concentration. So let's take a look at a rice table. Now, the R stands for reaction, so let's just write our reaction. Hey, what do you notice about the states of all substances in our reaction?
Yes.
Sweet. So it doesn't even matter whether it's Kp or Kc. We're good to use everything. All right, so I'm going to go ahead and do 2H2 plus carbon monoxide is yielding CH3OH.
Is carbon monoxide super bad for you?
Yes, it's super bad for you. All right, so the R is pretty easy. Copy down the reaction, translate it if they're mean, and don't just give it to you. Just bad glare there. The I stands for what? The initial concentrations, and that's what they're going to give you at the very beginning. But what do you notice about the units of those reactants that they're describing? Moles is no good. It's got to be molarity or pressure in this row. Now, the good news, though, is that to find molarity, it's moles over liters. What are the liters of this example? 1. So any number divided by 1 is itself. Hooray. We don't have to sweat it too bad. But make sure you look closely. So it's going to give me 1.06 as my molarity of hydrogen. It's going to give me 1.57 as my initial molarity of carbon monoxide. And then we don't have an initial of the product. Look back on the previous slide. What does it say we're going to do in that situation?
Make it says there's no product. So 0. So
It says give it a 0. All right, so that's going to be a very common practice as well. Putting a 0 beneath something that's not given initially. The C stands for change. This is where we're going to add, we're going to show what's going down and what's going up. We're going to use pluses and minuses for this. All right, you'll see down here. Oh, there's the 0 thing. Maybe it was on this slide. But we're going to be using plus x and minus x. Of course, x is what we're solving for, the equilibrium concentration. But what I know from Friday is that my reactants will always go down in amount, while my product will go up in the amount. The amount of reactants during a reaction goes down, minus. The amount of products during a reaction goes up, plus. All right, there will always be x's assigned here. However, the mole ratio needs to be taken into account. So basically, we just want to put an x in front of those changes, but the first reactant will be 2x. Do you see the coefficient 2 driving that? How did the slide say we're supposed to find E, equilibrium? Add them together. Yeah, add the I and the C together. So that's exactly what it says. All right, so we're going to go 1.06 minus 2x would be the sum of those two rows there. I'm going to go 1.57 minus x as the sum of the two rows there. And if you sum 0 plus x, it's the same thing as x. We all right so far?
Yes.
Now, there's always going to be another piece of information given. This is the part that really differentiates problems, because depending on what they give you for the next bit of information can make this a really easy problem like this one will be, or it can make it a super annoying problem like our third and final example today will be. But if you look, it tells you flat out that the concentration of the product at equilibrium is 0.2. That this guy right here equals 0.2. It says moles, but divided by 1 is actually going to be a molarity. So it gave us that number. And since all we had over there was x, I now know all of the x values, which makes solving the rest of this very simple. 1.57 minus x is going to be 1.37. .06 minus, hey, look there. What's that?
Times 2.
2x. Be careful. It's going to be 0.66. Everybody see what I'm doing? Now, I've answered 2/3 of the question, all right? Because it says, what is the equilibrium concentration of H2? What is the equilibrium concentration of CO? But what else does it want? It wants K, all right? It wants you to find K. Well, that's what we learned to do on Friday. So it's still no sweat. But hey, before I start plugging and chugging numbers, how can I get a free point on the AP?
Like the unsubstituted.
Unsubstituted equation. So I'm going to start off, and I want you to do it too. Don't be lazy. by saying Kc equals CH3OH over H2 squared times CO. All right, then we plug and chug. My CH3OH is 0.2. My H2 is 0.66. My CO is 1.37. Make sure you know how to do algebra. What's the question? There is no units for K. K is unitless.
Wait, what does that say?
In red,
Yeah.
this says the equilibrium concentration of H2. I'm just getting my answer. This is not connected to what you're doing right now with KC. Just trying to organize my final answer very clearly for the graders.
Kudos to you for pulling off rounding, not black. Kudos. That's good. Not a lot of people can do that.
Shirt, that's my favorite shirt.
Not a lot of people can do that, Mr. Cummings. You should professional.
It's crazy.
Some people be looking dumb when they show that.
How many more are you doing?
Isaac, I'm sitting here trying to figure out if you're messing with me or not.
No, this is
you actually
sincere.
do look good.
You look great.
You look like Steve Jobs.
Thank you. Here, more people say it. Just kidding. Notice what I'm doing here is, even though I've technically already answered the first part of the question, I don't want the graders to have to sift through my work. All right? They're going to already do that to give me credit for the work, but when they look for the final answer, this is a beautiful way to show it to them. All right? There's everything I've done to figure it out. Show the rice table. They expect the rice table. And then I know that my H2 concentration was 0.66. All right? And that one does have a unit. My CO concentration is 1.37. And then my KC is what? What'd y'all get?
0.30.
I got 0.34. Now it's clear, concise, gorgeous, like black on brown.
That was. Talking about yourself. I know. But your
Yeah,
pants
it
aren't
looks
even really
great.
brown.
Stop. Okay. You're overselling it. Yes, ma'am.
Yeah, it's not brown.
Yeah. I had 3, 2, and 3.
Okay.
Oh, I gotta show you the volleyball.
No, I mean this because this is fine. Now, technically, you could take molarity away and put it in brackets, and it would mean the same thing. But to put it with brackets and molarity would be repetitive.
Wait, Mr. C, would they take out points in the AP if you don't put the right number of statistics?
Yes. One. It's only worth 1 point. It's only 1 point, but yes, like automatically 1 point. Why would I be, dude? I wouldn't be making your life terrible for no reason. All right, let's do another one.
It's not, I don't know, I guess it's
All right, so let's look at another rice problem with a different, slightly different twist on what they could ask for. Again, the way I know I want to use a rice here, the word initially is a good indication that I might need to be using a rice. The fact that it gives me an equilibrium and wants me to find Kp associated with numbers that are not at equilibrium. So let's go straight to our delicious table.
So good. Cheese and rice.
I love cheese and rice.
R stands for reaction. Hey, are the states of our are the states okay for all of our substances?
Yes.
Would it be okay if one of them was aqueous?
No.
Why would aqueous not be okay here? It's Kp, so be careful. All right? Therefore, we're still good to use everything, so I'm going to go, all right, 2NO.
One question, Mr. Cummings.
I'm listening.
So if it's Kp, so if it's Kp, right, and it says one of them is aqueous, what do we do then? Do we just say no?
So what'll happen is it will still go into your reaction, and you're going to put a big X beneath the rest of the table and ignore it.
Okay.
You're going to get good practice doing that because we're going to find equilibrium of acid-base reactions in the next unit. Acid-base reactions always produce liquid water, and it will never be okay to use it. So we're going to be Xing that out a lot.
It's the R versus reactions is aqueous and gaseous only. Is that for KC?
For Kc is aqueous or gaseous. For Kp, only gaseous. I guess so.
The girl's choking.
Man, that glare totally misses my video. I did make it a little better. Okay. All right. I stands for initial, so let's go ahead and take a look. Now, we are given pressures here, so we got to be careful with a couple things in this problem. Because we don't use brackets for pressures. You remember that? What do we use instead of brackets when we're showing pressure? Parentheses. Guys, don't lose a point because you put brackets around a pressure, because they'll take a point
What
away.
is the reason why we do that?
Because by definition, brackets are shorthand for concentration.
Okay.
I just said that's a chemistry shorthand. So to use it around something that's not a concentration is just flat out wrong.
Okay.
Okay, so I do have some numbers here. I got 0.526 here. All right, for the BR2, it's giving me 0.329. Now I changed the lights, I can't see it anymore. But y'all have it in your slides, so y'all are good. All right, what am I going to put below my product? 0. All right, now someone said negative. Careful, I mean, you're right. A negative is going to end up below my product, but don't mess your rice rows up. All right, C is going to be my change. I know that my change for my reactants will always be negative, while my change for my product's going to be positive. Going to assign X's while paying attention to coefficients. Isaac?
Is there any time? Okay, so like, sorry. So is there any time like where would like the plus and minus would be such around if it was like a decomposition, or would we never do decomposition?
Nothing at this level is going to make the change be. In Le Chatelier's principle, which we're going to study on Wednesday, there's a way to make it shift the other direction, but that's not going to be the direction that will focus for equilibrium. Because the best way to do that, not to confuse you, would be to assume, okay, well, we're going this direction, so just write the reaction with that as the reactants. Does that make sense?
Yeah.
That way you don't have to worry. That way you can make it so it's always minuses and pluses instead of a swap. My equilibrium is going to be a sum of I and C. So let's go 0.526 minus 2x. Let's go 0.329 minus x. And let's just go 2x. Please ask questions if anyone doesn't see something there. Now, we can always get to this point. It's what did they give us? All right, remember last time they gave us just the ending equilibrium of the product, and then it was easy to solve for x. This time they make it just a tad twistier. At equilibrium, the BR2, which was one of our reactants, had a partial pressure of 0.203. It's telling you the solution to his equilibrium. It's letting you know, all right, well, when you take 0.329 minus x, it ended up equaling 0.203. Solving for x there should be very easy.
0.126.
All right. Hey, I have a value for x now. Now, realize, though, I have the equilibrium for one of my guys. What was the equilibrium of bromine?
0.203.
Yeah, it was 0.203. It flat out gave it. So I'm going to just put that in parentheses now. Because this, I already found the BR2. The problem flat out told you at equilibrium, BR2 was 0.203. But now that we know x, we can apply it to the others. All right? So my product is 2x, which looks like it's going to be 0.252. All right? And then be careful here. 0.526 minus 2x. So 0.526 minus 0.252, really. And I get 0.274.
So is that red number at the top right?
Yeah, so there they are in order. This is NO, this is BR2, and this is NOBR. All right? And that's why at the end, you'll want to really make sure you make it nice and clear. But yeah, I just wrote 2x above there. Sorry. What?
Where'd you get 203 from?
203 is given right here in the problem. Boom, 0.203.
Oh.
That was the extra info it gave us to push us forward in the problems. It's got to give us something. All right, let's write an unsubstituted equation. Now notice this only wants Kp, right? It doesn't even want these other numbers. So really, I don't have to do that thing where I clear it up at the end. It only wants Kp. Of course, I need those values for Kp. But anyhow, so we're going to say that Kp is going to ultimately be equal to NOBR squared over NO squared times BR2. There's my unsubstituted equation because I love 3 points. Going to sub in my values. My NOBR total was 0.252. My NO value was 0.274. My BR2 value was 0.203. Anybody else bring AAA batteries that they want to take one of my calculators? Did you bring 3 or 4? maybe these ones were 3. Dang it, why did I mess that up? Oh, they're all 4.
You know we don't call my calculator?
What's that?
You gonna take my calculator? You can do that?
I'm going to just let it. You can check it out.
Okay, wait, I'm gonna do that.
Oh, me and Dr. Daniel was that.
From me, you just bring me 4. Just bring me 4.
Just get everything done.
I mean, I'll just give it to you. You got 4.
But I didn't see it. Oh.
Your syllabus requires that.
No, I lost my TI.
I haven't looked at the words.
All right. Oh, sorry.
Yeah, it was.
Are we keeping this?
Here, just switch them out. Yeah, just don't steal it from me. Hey, somebody shout out an answer.
4.58. Oh dear God, what did I do?
I got 4.17.
Hey, I got it right.
All right, are we doing okay? Yes.
0.18.
Okay, I mean, there's, I don't know, maybe it is. You know that though my answer choices are close, they're not that close. All right, so what's the worst thing that can happen to you on a rice table? Let's take a look. Go ahead and switch it over.
This was the hardest one.
Yeah. All right, let's take a look at one more problem.
See, this is what I'm talking about.
No, I can't. I don't want you to.
Oh.
Chill out.
I'm dead. I like
Who wrote hello on my thing? Okay. The worst thing that can happen is that they give you K. Because when K is already provided and you're looking for other stuff in the equation, it's going to get quadratic. Which is why we want a scientific calculator to do it for us. And by the way, those of y'all at home, I'm going to have trouble showing you how to push the right buttons on your calculator on the video. So maybe I'll figure it out as I go. But I'm sorry if I'm not helpful. Here's one of the things about your calculator, though. I have a calculator here at school and a calculator at home that are two different models that require different buttons to be pushed. But if you have a scientific calculator, you've got a solver on it. All right? There's just a chance that I won't be able to look at it and be like, oh, it's this, 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 and this. But the one at home, for me to figure out how to do, I just had to Google the name of the calculator with the word solver, and it came up with 6 buttons to press. So if I'm not helpful because I just haven't used your model before, it's easy to find. Now, if you have an Inspire, I'm told that the way to do this with an Inspire is far easier than using mine. Now, I've never used an Inspire, so that's great. Kudos to you. Can you use an Inspire on the AP exam? I have no honest idea. I haven't looked at that calculator list, but I'll try to find out for you soon. Okay. Anyways, let's take a look. It talks about equilibrium, but it talks about building the reaction from start, which means things are going to be happening initially. So I'm going to open up with a rice table. I can see that my starting reaction includes everything gaseous. So yay, none of my problems tried to trick us. During lecture, at least. Guys, it's good when you run into, if you can recognize that something's not used because of its state of matter, you just get to ignore it exists. So it's good news when it happens.
I think you appreciate raising Dion. It's got chemistry and biology stuff in there. It's really good. I cried 4 times. Oh my God.
Okay, it's a Netflix thing, I think. We're going to take a look at our initial concentrations. Now, take a look. It actually only gives me an initial concentration of PCl5. What is it? What is my initial concentration of PCl5? It's 0.2.
Where did you get the 2 from?
Because it gives you moles and volume of 2. To find molarity, it's moles divided by liters. So she divided 0.4 by 2. Everybody see the little math that happened there? Now look, I do not have concentrations for the other 2. My change will be minus plus plus, of course. Are there any coefficients to worry about?
No.
We all right?
Yes.
Nothing different yet?
Yeah.
All right, let's sum up I and C, and we'll see what happens here. It looks like we're going to have 0.2 minus x, x, and x. The extra information given in this problem is K, which means while we can plug and chug now to try to find these equilibrium concentrations, it's going to look different than it did before. Now, if I'm going to set K up as an unsubstituted equation, because we always do that, We are going to use brackets again because this is not pressure. All right, so there's your unsubstituted equation.
Wait, how do you know what to put at the top?
Products over reactants. Let's get some values in there. Now, we have a Kc. Our Kc is 33.3. As I input these, it's X for both of my products. For those of y'all that know what a quadratic is, you can see it forming there. And on the bottom, it's 0.2 minus X. All I did was put the numbers in. Nothing should confuse you yet. In a perfect world. We all right?
Yes, sir.
Now, because of all these X's that are hanging out, I want to simplify this equality. All right, the way that your brain should naturally simplify it is to cross multiply. If I cross multiply, I'm going to be distributing the 33.3 to each of these factors. So 33.3 times 0.2 comes out to 6.66. I like it when the walls bleed.
That's on video.
So we got that out?
You have officially announced it.
Anyway, 33.3 times x will be 33.3x. And then what is 1 times x times x? X squared.
Are we factoring this?
Now, no, we don't want to. That's the reason you have the calculator. We don't want to solve this by hand. All right. What we want to do is have the calculator do it for us. Now, here's the thing, though. In order for the solver to work on your calculator, it has to be a 0 equals equation. All right. In other words, everything that is part of your expression has to be on the same side of the equality for it to work. Now, that's easy to do, but here's my suggestion to simplify possible road bumps. Is you don't ever want the x squared to be negative if you can avoid it. All right, don't make the x squared negative. So in other words, let's bring the other stuff to him. If you do that and manipulate the variables, you'll end up with 0 equals x squared plus 33.3x minus 6.66. We can go on a field trip. Maybe this will work. Make you sick. Oh, does everybody back here consent to maybe being on video?
Yes.
We're good? Everybody's good?
Yes, let's do it. Alyssa, come on, we're gonna keep us up.
You're going to have to... I need to be on the document camera. I'm sorry. Wait, what happens if I do this? Oh, it breaks the computer. Awesome. Okay. Dun dun. So, with your calculator out, here, just go join. Just go join her.
Michelle?
No, I call most of y'all by y'all's
Pronoun.
last name, actually. So I was gonna go Tran, but what?
You're what?
What is funny? Okay. Anyways, take a look up here. Now, if your calculator is not a TI-84 Plus, again, it will have this capability, but the buttons might be somewhat different. So here's what we want to do. There's a math button right here. All right, some of the older calculators actually have a solver button either up here or over here, so look there if you don't see the math button. But if I hit math, it's going to give me these options. The very last option is solver. So I pushed up to go to the bottom of the list. And from solver, I hit enter, and you'll see that it's already setting up a 0 equals equation. All right? So for those of y'all at home, I went to math. All right, and then I used the cursor to find solver and hit enter, and it came up looking like this. All right? So now from the 0 equals, we want to duplicate our expression. X squared, well look, there's an X, there's a variable button right here. I can make an X appear. There's a squared button right over here. I can make the squared appear. Plus 33.3x, so 33.3, and again, I've got a variable button up here to make the x appear. And then minus 6.66. Any questions? Now, I've duplicated the expression that I came up with in my rice table, and I'm going to hit the enter button. And when I do, it'll take you to this screen. Now, the TIs require you to put a guess for x in there before it solves it for you. I always use the value 2 because it's never steered me wrong. So I am guessing 2. And then I want to click solve. And here's where it's definitely different on a lot of calculators. The solve on this calculator is the alpha function of the enter key. So what I have to do is go to the alpha button, which is up here below second. And when I hit it, you'll see my cursor starts blinking with the letter A. And now if I hit the enter button, it'll activate solve, and boom, we have a correct answer to the problem.
What's the answer?
Now I know.
Oh. I was like,
Wait, so what do you say?
Hang on, I'm gonna go finish the problem. Yes. Well, and we solved for x. Now we got to figure out what the question's asking. All right, so the question was, okay, well, so that's just your answer? Well, remember what we found. We found the value of x. And now, like, if it wants the concentration of PCl5, well, no, that's not the answer. It would be that number minus that answer. So make sure that you realize what you got. But what I have here is x equals, I lost it, 0.199, I think. Yeah, 0.199.
Because you solve it. I mean,
you round it up.
you definitely lost. Okay. Very good. Well done.
Now, it's an equilibrium concentration that we have found here. All right? Oh, no, it's not. It's K. Oh, no, it's not. It is equilibrium. Like, I'm bouncing back and forth. Having hiccups. Sorry, K is 33.3. Need lunch. Yes, ma'am.
what if they don't let you use those and
They let you use the TIs for sure.
Oh.
My calculator that I just used, you can use
Okay.
for sure. It's the Inspires that I don't know. But I've never used an Inspire, so I have no idea. Now, what did this want us to find? It said calculate the equilibrium concentration of each species. So it wants to know all of those X's. So then I can say, all right, well, if I'm working backwards, the Cl2 concentration at equilibrium is equal to X. So that's 0.199. All right. The PCl3 equilibrium is again just X, so 0.199. And then the PCl5 is a little different. Because you have to subtract. All right, 0.2 minus X is going to be 0.001. Questions?